Welcome to the introduction to virtualization using zVM. In this part we will have a closer look on how virtualization works with zVM. My name is Philipp Brune from Neu-Ulm University of Applied Sciences. If you look at the overview slide, history and evolution of mainframe operating systems, we see that there is a separate path here for VM, or what now is called zVM. And you see that it has been around for a long time, the origins dating back to the early 70s and late 60s. And while the name changed over the years, the basic structure has remained. And zVM is the product that allows to do software-based hardware virtualization on the mainframe or the set systems architecture. So zVM is a mainframe operating system, and to understand how hardware virtualization works, not only in zVM but of course also there, we should have a closer look on the underlying mechanism. If you look at any kind of CPU that allows virtualization or supports virtualization, supports virtual memory and other more sophisticated things, then typically these kind of processors have at least two, maybe even more, different states, internal states, and they have the possibility that some machine instructions are not executed in all of the internal states. In this example here, you see the basic structure inside the mainframe CPU. We have that is called the problem state and the supervisor state. So the mainframe processor can be in the problem state or the supervisor state. And in the supervisor state, only in the supervisor state, certain machine instructions will be executed. If certain machine instructions are executed, or these machine instructions are executed in the problem state, or if a program tries to execute them, there will be an exception, which leads to an interrupt that needs to be handled. So in general, modern CPUs distinguish privileged and non-privileged machine instructions, and privileged instructions are only executed, or it's only allowed to execute them in sort of a privileged state of the CPU, in this case called the supervisor state for the mainframe CPU, and not in the problem state. What kind of instructions are typically privileged? So privileged instructions typically are all instructions that are needed to, for example, initialize the registers for setting up the virtual memory management, for controlling the CPU itself and so on. So everything that of I/O operations, everything that basically an operating system needs to do and not a user program. Whereas in the problem state you can execute all the so-called normal instructions like arithmetic and logic instructions, branching, jumps and load and store operations and everything that every program needs to do. So the basic idea is that a modern CPU makes processing more secure by executing privileged instructions only in a privileged state. So if you write an operating system or the operating system kernel, it usually will execute mostly in the supervisor state. And every time a program makes a call to the kernel, it makes a so-called supervisor call. This is an instruction, as it is called on the mainframe CPU, that switches the state in the supervisor state and executes the appropriate kernel function. So what happens now when you do virtualization? Virtualization means when you start up the system, the first thing that is started is the hypervisor, the virtualization software itself. The virtualization software itself on the mainframe, this would be, for example, zVM, is running as an operating system and is sort of occupying the privileged state and is running as the basic operating system. So when this zVM now should start or should execute another operating system as a virtual guest, what it has to do is basically to run the full operating system, the guest operating system, including its applications in the problem state. This, of course, what's now is happening is when you start an operating system in the problem state, the first time the operating system kernel of this guest system tries to make some privileged call, privileged instruction, it will get an interrupt, it will trigger an interrupt, and the supervisor, the program here will be informed and has to handle that. And the idea of a hypervisor is now every time the guest operating system creates an exception, then this exception is is trapped and handled, and there is an appropriate handler in the hypervisor, the virtualization software, that then ensures that handling this exception leads to the same result as it would run on a physical machine. So the guest operating system can continue afterwards, and control is returned, and it continues until the next privileged instruction occurs. So, and by this mechanism, the hypervisor is able to simulate, sort of, or emulate virtual hardware and present the virtual hardware to the guest operating system. So this is the way how all hardware emulators basically, hardware virtualization solutions basically work. And this is also the case for zVM. And of course, this creates some sort of overhead, because every privileged instruction that a guest executes has to be trapped and handled. This is different for para-virtualization, as we learned in the introduction part, because in para-virtualization, the guest operating system is changed, and every time it wants to do something privileged, it just calls a respective function of the host kernel. So this is not sort of monitored and trapped, but it's directly calling the routine. So this overhead is reduced in that sense. In para-virtualization, of course, you need to adjust and modify the guest operating system, which cannot be done for all operating systems. Modern CPUs offer hardware support for this problem, and also the mainframe CPU for many years already offers special hardware support. So let's have a look on zVM. zVM, as we learned, is the hypervisor. So it's basically, this is partially true, because zVM in total consists of two parts. zVM is the product name, and it has two parts. The first one is called the CP, the control program. And this is actually the actual hypervisor software. And the second part is the CMS, the conversational monitor system. The CMS is itself a small operating system. It's a simple single-user mainframe operating system that allows interactive work at the machine. And it was originally implemented as a tool for software developers to program applications that should later run on, for example, MVS in these days. So it's basically a tool for software developers. It's it offers an editor, programming environment, and so on. So that was the original purpose. But then, in combination with the hypervisor, nowadays it's not used as a virtual guest for production use anymore, but it's mainly used as the administration tool for the hypervisor. In principle, CMS is a virtual, or is a mainframe operating system that runs as a virtual guest on the control program. And the original idea was that every developer got his own virtual guest. So it's a single user system, but if you have many instances of a single user system, then everyone can work. So every developer could have a virtual guest, isolated environment. This kind of usage today is not relevant anymore, because developers usually work with other tools like Eclipse and PCs and so on. But CMS is still used as the administration user interface for the CP. So when you start zVM, you basically boot the CP or IPL the CP, and then when you log in, you have first the CMS as a sort of a console to give commands and configure the system. And then you could start and run as guests other operating systems. Today, mainly Linux. So it's very common to run Linux, many Linux virtual machines as guests under zVM. But in principle, every other mainframe operating system would work. So ZOS can be run as a guest as well, or even zVM can run as a guest on itself in a way. So that is possible. And the idea is that nowadays, when you work with the system, you usually log into the CMS, and then you can issue CP commands that directly affect the hypervisor. So that is how CMS is used today. But we should keep in mind that zVM has always these two levels, CMS and the CP. Thank you very much.